I'm going to save this, and I'm going to say with birth-death now, okay? Instead of first SIR model with open population, I'll call it. It's an open population. People coming in, people leaving. Okay, ladies and gentlemen. Suppose we were to add births and deaths. And for simplicity and just to understand the effects, we're going to have births occurring at the same rate of deaths. But let's add births in. So how do we add births? Okay, add a flow. Yeah, so we add that flow in up here, and we go into susceptible, and we have births, okay? We're assuming no what's called vertical transmission. So in other words, all the infections, all the births occur is susceptible. The baby's not already exposed to flu when they're born or not already exposed to pertussis. They just come into the world susceptible, okay? So we added a flow into susceptible, okay? Okay, and now for deaths, where are those deaths going to occur? Someone said it earlier and they were correct. Where are they going to occur from? From whence will they occur? Sorry, from every stock. Yeah. So, okay, so this will be death of, or deaths to be consistent with births, deaths of susceptible, right? We could say deaths of susceptibles. I won't quibble with that. And then similarly from infective, deaths of infective people, and then recovered deaths of recovered. Okay? Oops. So let me go edit that. I'm going to go into that mode to edit this. Death of recovered. You know, there's something grammatically I don't like that. I'm going to make it deaths of susceptibles. So I edit that, I go into this mode again, and I just click on these, and I can do deaths of recovereds. Okay? I just find that better name. Okay, so ladies and gentlemen, let us call the birth rate. Let's create a birth rate. A chance per day that a given person in this population will give birth to a baby. So we're going to create a variable called birth rate. What sort of variable will this be? It'll be a constant. Okay, it'll be a constant. Okay, and births, the number of births per day, what does that depend on? Oh, it depends on birth rate, to be sure. What else? Total population. Thank you, Kurt. Now, it's getting on the messy side. I'm tempted to try to clean it up. So just because this is being recorded, partially because it's being recorded for posterity on YouTube, I'm going to kind of go up here and try to sort of clean this up a little bit. And now we're going to have total population. Depends on that. So births, what's the formula going to be? Birth rate times the total population. Each person on a per day basis is going to have a certain birth rate, a certain chance of giving birth, and so we're multiplying the birth rate times the total population. Does that make sense? So it's going to be a chance per day that someone's going to give birth, and how many people could give birth? Well, it's the size of the total population. Okay. Okay, so that's good. So we're going to have a mortality rate, and I'm going to introduce a use of to answer Fahad's question again before, the question from before. I'm going to introduce a shadow variable. First, we're going to have a thing called mortality rate, okay? Actually, sorry, we could even do it better than that, so we don't have to use the shadow variable. I'll drag that birth rate to here, and I'm going to create a variable called mortality rate. And mortality rate will happen to be right now the same as the birth rate, okay? But later we may wish to change it. So, ladies and gentlemen, deaths of infectives and deaths of recovereds and of susceptibles, what does that depend on? I'll give you a hint. The mortality rate is the same as a death rate. So what does this depend on? On what does this depend? Yeah. Okay. So death. Sorry? Okay. So deaths of susceptibles, what does that have to depend on? If there's. Okay, yeah. If there's no one to die, there's not going to be any deaths. Similarly for infectives, similarly for recovereds, right? That's clear. What else does it depend on? Mortality rate is a death rate, so it has to depend on the mortality rate. There we go. Okay. So, ladies and gentlemen, for the birth rate, I'd like to make it 2% per year. In other words, 0.02 divided by 365 per day. That chance per day is approximately that divided by 365. Okay, so that's 2% per year divided by 365. Now, maybe because Fahad was interested, I think I'm going to have, and I think Kurt was also asking. So I'm going to actually, so this is called a daily birth rate. This is a daily birth rate, which is an unfamiliar concept. I'm going to have an annual birth rate. And I'll show you how you do the units for these, okay? Annual birth rate. And the daily birth rate will be the annual birth rate divided by a quantity days per year. And so we're going to have a daily birth rate be the annual birth rate. So I'm going to get rid of this. It'll be annual birth rate divided by days per year. Okay? Does that make sense? Okay. And annual birth rate will be 0.02. That's much easier for me to think about. And days per year will be 365.2524. So, okay. Right. So what's the formula for deaths of susceptibles? Well, it's the death rate times the number of susceptibles. What's the formula for deaths of infectives? Speak, use. Okay, the mortality rate times the number of infectives. Okay, and then deaths of recoverables. Deaths of recovery will be recovered times. Oh, you know I'm violating this. It should be mortality rate times recovered for my convention. I'm putting the coefficient before the stock. Okay. Okay, and the mortality rate we'll just set it. This should be daily mortality rate too, since these are per day things. And daily mortality rate would be the same as daily birth rate. Okay? This is great. Yes? Yeah. Yes. Good point. Well, okay, it depends what sort of infection it is. If it's an infection like, well, there's many of them, but certain types of infections are going to be very, very mild, like a cold. You're not going to die from, and so you're going to have a similar death rate. If you wanted to have a death rate specifically from that illness, let's suppose it was a serious enough illness to be worth it, like even something like flu for certain people can be deadly, actually. Then we could have a separate flow be deaths from infection, and it would only occur from infective or infected people. Does that make sense? Yeah. Okay, so ladies and gentlemen, you'll notice that the formulas for susceptible are still indicating it needs something filled in. This is just to alert you that it may need something filled in. If you go and you look at it, it's perfectly fine. It's the flows in, bursts, minus the two flows out, deaths of susceptibles minus infection. You're fine. Same thing with infective. You're fine. Same thing with recovered. It's fine. Okay. And just as a nod to Fahad and Kurt's question, if we wanted to have this daily birth rate, what is daily birth rate? What's the units of that? Okay, it's actually, let's think this through. Daily birth rate. Bursts, what's the units of the birth flow? People per day, right? So what's the formula for this? It's total population, which is measured in what? People. I could even go say that. I could say this is measured in person or something like that, or people, I could have said. Okay, person, okay. So that's total population. And then I'm multiplying it times a daily birth rate. And I get bursts per day, person per day. So bursts, this flow is person per day. So what must daily birth rate be? Per day, 1/day. Okay. Okay. How about an annual birth rate? Per year? 1/year, in other words? And how about days per year? Okay. Days per year. Does this check unit-wise? So we have a daily birth rate that's 1/day. We have an annual birth rate that's 1/year. And to get daily birth rate, we we divide by days per year. Does that work out unit-wise? It turns out it does. Annual birth rate, units. So annual birth rate, units 1/year. And we divide it by days per year, right? If you divide this by this, what do you get? 1/days. You can just flip this over, multiply it, the years cancel, and you get 1/days, right? It's so it all works out, and Benson could check that in terms of units. Yes, Fahad. Right.
Using a formula, or how can I assess that? I want to know how can I use the source to read from that.
Oh, okay. So in Vensim, there are these so-called formulas, like we saw ZIDZ, ZIZDZ before. There's like ABS or whatever for absolute. There's these ones to get random numbers, and some of them can be used to, and I don't know if it's in Vensim PLE, I'd have to look. But there are some that can be used to draw values from a spreadsheet. You can also do under model, is this in here? There's certainly the version I use, there's a potential to import data set. Looks like it's disabled for this one, but in any case, if that's a need, I can set you up to do that, okay? And it could read things in from Excel files, or you could read things in from text files, etc. Okay? Okay, so ladies and gentlemen, so I'd like to run a baseline. Yes? Question?
What happens if there is unit and the correlation of the unit and the formulation?
Right. Okay, so it's a good question. So here, one of the reasons I want to show this was to answer the question, suppose we have, we have things which are of different units. To what degree does it enforce it? Here we have something of a different unit, right? The model's units, what are the model's units of time? It's per day. We can go up model settings, it's per day. Here we have a quantity that's specified in a different time unit. That's all fine and good, and actually Vensim could check these things, but where the rubber meets the road, where it becomes really key that you be consistent is if you're having a formula for a flow, it's got to be in terms of the time units that Vensim expects, okay? And so here, you're going to need something that's person per day, and it's up to you to make that happen, okay? Why per day? Because that's how flows are measured in a model whose units for time are days. So this formula, you can use lots of units elsewhere, but when it comes time to give a number for a flow, what that means is an amount per day, okay? And so as long as you can be consistent, and that's what I was consistent here, I converted from this number to a daily rate before multiplying it times bursts. Yeah.
What happens if it's not understand
Hmm.
which one the wind can take? It takes it from the formula, or is it that it's
No, no. The unit could be used to flag a problem. So we can actually tell Vensim, and I'm trying to remember here, there's actually a units check here. So we could tell it, go check the consistency. And if it sees us using something for a flow that's not in days, it'll say, wait a minute, you're dividing the stock by a year, number of years, and that doesn't jibe. That doesn't line up with what's needed for the flow. And so we'll say you're trying to set something that's a formula, a number that is like 3 person per year, and you're trying to use it as if it's 3 person per day. It's not consistent. It would flag you that. But in terms of what it actually uses, if you tell it just run, don't check, run, it'll just use it. Does that make sense? Yeah. So that's what's going on here. Okay, ladies and gentlemen, we're almost done here. So let's run a baseline with this open population. How will that differ? So I'm going to say baseline open population. How will that differ? How will it differ? Did the infection previously, did it go extinct? What happened previously in that previous run for the baseline? It went up and down, and was it ever going to pop up again? No. Because it burnt through. It's like the fire in the fireplace. It burnt through its fuel to the point where it couldn't burn efficiently, and it went out. It went down and down and down and down and down and down. But asymptotic approaching zero. Never gonna rise again. Okay, ladies and gentlemen, here what can happen instead? Okay. So we're going to run baseline open population. So maybe there's another peak. Okay, that's unexpected. Okay. First of all, let's go check if bursts are occurring. Zero bursts. What's going on? What's the daily birth rate? What? Huh? Okay. Okay. I did an annual birth rate of 0.02. Yeah. So the daily births. Yeah. Huh? Okay. Well, that's a good question. So there's a daily birth rate times total population, and total population here is susceptible, infected, recovered. Okay, ladies and gentlemen, this is puzzling. Okay, so here we have the total population kind of around 1,000. But we have bursts equal to 0. This is.
No, it's gonna go into the baseline.
Oh,
Is it?
sorry. Am I only doing baseline? I'll get rid of those two. Okay. Here. It's still 0. Okay. This is the most puzzling. This is a great opportunity to watch model debugging. Okay. Here we have people coming in at a rate of about 1 person every 20 days, okay, right? And
The birth stays constant, but it's still there. Or is it
births is, let's go see what it is. No, it's almost constant, yeah, because the population is just about constant. So that makes sense.
when you plotted it, or is it
It's just close to 0, yeah. Okay, so infection prevalence here, it rises and it falls. I think the birth rate must just be so low as to not be making a difference. Let's try a baseline, and let's do an alternative open population. Alternative. Okay, now I want to suggest something that will speed up this whole thing. So what I'm going to suggest is in model settings, you'll notice that there's this thing, save results every time step. We unclick that, okay? And we'll save results only every 1 time unit. This is going to speed up a lot sort of how quickly it displays, okay? So let me rehearse that again. I went to model settings, I unclick save results every time step, and I said use save per equal 1, and then I'm actually going to rerun the baseline, so it only saves it that often, and then I'm going to rerun, and then I'm going to run an alternative one, okay? And I'm going to run that in synthesim mode, and you'll notice it's quicker, okay? So here's this, okay? So now let's move up this birth rate. I'm going to move up the birth rate to be 20% per year, okay? I want to see. Oh, is that okay? Okay, it sounded better than my computer a few weeks ago. Okay, so the infectives. Sorry. Oh, okay, good, yeah. So here we have a situation where the number of susceptibles is rising up. I see. Yeah, part of the issue is we're only running this for 1,000 days, which is actually not that long. Okay, I'm going to say an annual birth rate. I'm going to say an annual birth rate of 1. Now the fox has shown its tail. Okay. So now we have a quite. So if we have a turnover basically of once a year in the population, that's when we start to see these sort of spikes in the infection prevalence. Let's lower the annual birth rate to 0.2. So that means how often, on average, does it take for the population to turn over? If we have a birth rate of 0.2 or a death rate of 0.2, that means the population turns over in about how many years? 5 years, 1 over 0.2, okay? So here we have a situation where the infection is going down, but susceptibles is rising. Eventually it's going to rise to a level where it'll outbreak again. It's not yet at that point. If we increase transmissibility, say if transmissibility were 0.16 instead of 0.04, for example, now we might get in a situation where we have secondary outbreaks, for example. So with a highly contagious transmissibility, so by the way, let's just think about this for a second. Transmissibility of 0.16, that means each person here will on average infect how many people before recovering in an otherwise susceptible population? What's that? 16, I think.
Oh, yeah.
0.16 times 100, 16. Okay, and the annual birth rate is 0.2, so that means the population turns over in about once every. Remember, these are all first-order delays leaving here. We have a chance per day, a chance per year of 0.2 to leave. That means on average we stay here how many years? 0.2? We stay there 5 years. 1 over 0.2, it's just the same relation up here. Okay, so what this is saying is with a basic reproductive number of 16 and about every 5-year turnover, you start to see these, well, you get these secondary outbreaks within the population here, for example. And that's actually about what you see for something like measles. I mean, measles has a comparable basic reproductive number in some situations. You know, if you were to make it 25, you would see these secondary outbreaks as well. But here we get a situation where the infection stays endemic, although at very, very low levels. It's actually remaining here. You could barely see it, but some people are remaining infected at any one time. Okay, so in the final little component here, so this is our model with open population. So we've saved that. I'd like to do one final thing. We could do it, I think, quite quickly. How if we were to add in a vaccinated stock? Okay.